think it's good, but it doesn't appear on my channel. I'll forget about it. This is good. This is good. I think it's good. Yeah. Okay, let's continue. Excel. No, then it is What the fuck is this, bro? Oh my fucking god. My let's go out. That's correct. That is C out. Like that. This is the C out. I'm just gonna place it over here. Cause why not? Now I'm gonna take that C out right here. I'm gonna say sum here. It's gonna be like that. Just close this a bit. Right, that's nice, I guess. But on the dot here we have the little flutter thing, template. Yeah. So instead of F, so I'm gonna do FA0 for example, flutter 0, and you input. So inputs. So small inputs. Some output, okay, then C out. It's just sum. Let's just call it sum. I think it's better when you call it only sum. Control S. Now this can go right over here because we don't need that. because we're pros here. No, we're not pros here. So so this is nice. So let me export it. Export image outside my vault. The scene is gonna be light. The template's gonna be the full other template. Save that. Windows 2. I mean, it's not Windows now. It's Super. So that is a template, and I'm gonna say adders, decoders, and multiplexers and shifters. Yeah. Example one. So this is the full adder template. It's good. So and then the example 2. So example 2, adding 4 for example, adding 4-bit sequence. Here we are not adding something like this. So 1 plus 0 plus 1 plus 0. Instead, we are adding something like this. So 1 0 1 0 plus, what do we say? I'm gonna say 0 1 1 0. So plus a sequence dot. This is where I will need to explain. What do I need to explain? Parallel and series. Series and parallel. So info. It's for the moment, okay. Difference between between series and parallel. So what do they say that no, I can't do that right now. Study. This is the diagram for adding 4-bit sequence. It composes of consists of it consists of full adders in series. Undo series. So they are also known as undo paste. Now in series consists of in series dot. So I'm gonna have to make my fucking god. Just F0 plus asset F0 control S control put the assets control C control C I was about to delete that. Add template add a 4-bit addition 4-bit addition sequence addition. So I'm gonna place this here. Control C, Control V, Control V, Control V, and then so let me get my drawing tablet. Just give me a second. Can you hear me? I hope you can hear me. Loud and fucking clear. Oh yes. Where's my cursor now? Control Z. Oh, but I don't have a cursor. Okay, I just have to guess. Oh, but then then just better for me to open up my paint. Just better for me to open up my paint. So Control Z. Okay, so the layer, the background chooser, and this is I want to save as default. So now the B. No, I don't need that. So C. So for example, if I'm doing 101 plus 1010. No. Let's see. What did I say? I think 10 plus 0110. If I'm gonna do that, I'm gonna have to do, for example, 1010 plus control Z plus 0110 0. Now what does this give me? This is going to give me 0. Now what is 1 plus 1? 1 plus 1 is 0 carry 1. So 1 plus 0 is going to be 1, and 1 plus 1 is going to be 0. So it's going to be carry 1. 1 plus 1 is going to be 0 carry 1. Carry 1 here. So you know what I'm saying? So it's going to be 0 here, and it's going to be 1 here. So all of this becomes 0. And for example, this is 8 plus 2 plus 4 plus 2. 8 plus 2 is 10 plus 6 is equal to 16. 16. And this is obviously 16. So B, no, it's not B, it's C. C, and this is obviously 16, so the answer is good. So, oh wow, okay, V is color for palette, okay, nice. Yes, as you can see here. So if we're adding something like 1 plus 1 plus 1, control Z, V, if we're adding something like 1 plus 1 plus 0, this is going to be a 1. No, it's gonna be a 0 and 1. I'm fucking joking myself. I just learned this yesterday and I fucking forgot. So yeah, it's a yeah, so it's a sum 1. It's a sum becomes 0 and the carry becomes 1. So carry out becomes, what did I say, 110. Yeah, it's good. And the carry out becomes 1. That's correct. But in this case, this was done using a full adder. Only one full adder. This is done using one full adder, because you get the sum out here, and then you get the carry out here. I'm just gonna go CO. If you're going to do this, you will have to do something like this. So again, B, no, it's not B, it's V. So 1010 plus 0110. This is going to be something like let's get a good color here. Something like, so you get your inputs A and B. So again, I said this is going to be 1 0 1 0, and then this is going to be 0 1 1 0. Think of this as A, and then think of this as B. So for if I do not, it's not just V. If I do something like you will understand what I'm trying to say. So if you do this, and then you have control R, you have this, and then you have the so you have the input here. So you have the input over here. Did no, I don't know. So youtube.com ripple carry adder. So my ripple carry adder, and then this is yeah, so it's C out. So
2 4-bit
okay,
adders.
it's C out is equal to 0. Okay, I get it now. Oh yeah, this is the video I was using. So this is C out. C out is equal to 0 at this point in time. Now if we're doing A and B, so A and B, this inputs, so A and B, this inputs, you get the sum of 0, and then you get the carry out of 0. So it's equal to 0. The sum is equal to 0. Now this is a full adder 1, full adder 0, for example, and then this will go to something like this, FA1. Now this will take A and B. In this case, A was 0 is equal to 0 is equal to 0. Is equal to 0. I'm sorry, is equal to 1 is equal to 1. So this sum becomes 0, and then this carry here becomes 1, and then when this carry becomes 1, oh yeah, I forgot now. So A and B, so you have this carry, so FA3. This is going to be sum. So we did this, so this is 0, this is 0, this is 0 also, carry 1 here, so I carried 1, and then this is 0, and then this is 1. So I think it's a 0 plus 1 is gonna be 0. I'm sorry, 0 plus 1 is gonna be 1, so 1 plus 0 is equal to 1, and then the carry out from here goes into that, so it becomes a carry out of 1. Yes, because the sum is going to be 0 because you're doing C out, so 1 plus 1 plus 1. I'm sorry, 1 plus 0 plus 1. We could say 1 plus 0 plus 1 because the carry out is here, so C out is here. So this is C out, then here. This is C out, and then this is A, and this is B. So this will obviously get you the carry out of 1, and then the sum of 0, and then this here is FA4. Now FA4, you have carry out of over here, carry out. So now this is as I said 0. Now this is going to be 1 here, so you have 1 plus 1 plus 0 plus 0, A and B. So this B is 0 here, and then this one is equal to A. Now you're gonna get the sum of 0 again, sum is equal to 0, and then you're gonna get the C out of 1. Now this C out here, this C out will go obviously, so V, no, it's V, yes, this C out right here, it's gonna go to 0 1 here, so this is C out, and then it's gonna do so 1 here, and then this is 0 here, so that then the answer becomes answer is equal to 16. There it is, the answer. But is this correct? Let's go back and watch the video. Do I get copyright strike when watching this video? Oh, I don't get copyright strike. I don't know.
We can also build the 8-bit adder. A1 adds the 2 bits A1 and B1 along with the previous carry C1, which is generated from the previous adder. This carry bit C0 is set to 0. So for the first full adder, the sum bit is equal to 1, while the carry bit is equal to 0.
Oh, now I understand one thing. Look at this point. This is C0 is equal to C out is equal to 0. Now you know that you have control V. I don't know. You know how you know that you have this. For example, 0 0 0. So 1. No, this is not good. So let me do it here. A, B, and C. 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1, and then 0 1 0 1 0 1 0 1. In this case, where is our C out? Where is scene? I'm sorry, scene or C out? Where? The thing is, it can be here, it could be A, so this part, it could be this one, or it could be this one, because it starts with 0. All of them start with 0, so you can have C in here, you can have C in here, or you can have C in here. I usually do C in like 0 1 0 1 0 1. It doesn't make a difference, by the way, but I usually have C in here. I usually know. No. I like scene to be 0 1 0 1 0 1. Yeah, and then you do your calculation. So sum and carry out. Yeah. So I think this is good.
So now this carry bit is the input to the next adder, and for the next adder, this A1 is equal to 1, while the B1 is equal to 0. So the output sum bit is equal to 1, while the carry bit is equal to 0. Similarly, for this 1, that means is equal to 0. So now for the D3, sum bit is equal to 0, while the carry bit outgoing the 4 full adders, we can
see. So my paint. So see here we're adding 4-bit sequence, so V, and then I'm gonna say red 4-bit 4-bit sequence. So in this case we're using 4 full adder. If you had something like 1 0 1 0 1 0 1 0 plus 0 1 1 0 1 no, 0 0 1 1 0, this is gonna require 8 full adder. Again, starting with the cout 0 and ending like it's gonna have like parallel. Now we're gonna get to parallel and so series. So I understand now. I understood. I just need to do that again here. So let's get to business. So you know how I said series versus for example parallel. So series versus parallel. You know what's the difference? The ripple carry adder is equal to a parallel adder. So parallel symbol. Why is it called that was my question. Why is it called parallel adder when the full adder are like this? So you get my point. So FA1, FA, 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 and then FA. Oh my god, FA, and then it just keeps on continuing. You see, this is in series. This is in series, my friend. This is not like resistors in series. This is parallel, obviously. So how do you make a resistor in parallel? So this is in parallel, obviously. So I was like, what the fuck? Why is it called a parallel adder? This is because the bit addition is simultaneous. That is why it's called a parallel adder. The structure, so Control Z, the V, the structure is in series. The structure is in series, as you can see my lecture said, but the fucking addition operation is in parallel. Understood it. Control delete. Let's get back to business, my friends. Let's go back to business. So do I have no, it's not reflex. Yeah. 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 So I need so T XL. I mean the large. A is gonna be green, and then B is going to be yellow. So I can have something like okay, let it be like that. Control A, Control V, Control V, Control V, Control V, and then I'm gonna align. Can I align that using so this, and then this? Can I align them like so? And then can I move them like so? Yeah, nicely done. So, but can I also do something like this, and then this? No, but this is nice. So it's just gonna do like that now. So like so, like so, like so, like so. So now this is going to be great. So we can now delete this now. Control X, Control V. I need to center this one out now. Control C, Control V, Control V. So this is going to get like so. This is going to be like so here. Control C, Control V, right over here. This is really nice. This is really nice. And then the C out. Oh my fucking god! I need to put the C out. So C out. So I'm just gonna do something like, so it's gonna be in black, and it's gonna be in like fucking C underscore O. That's it. I don't have time for this shit. There's many things to do. So C out is gonna be somewhere around this, and then I need something called a fucking this, bro. So no, it's not centered properly. Yes. Now I can say that the C out is equal to the C out was and is equal to. Oh my fucking god! This one I need to delete. No, Control V. Delete this. No. Delete this one also. Now, take the small. No. So take this and put it small. Medium, large is fine. Large is fine. And now, I'm gonna say small letters. I'm gonna say out. O. Just O, I guess. Now this O is gonna be grouped into here, and then this C0. So no, how did it do it? C1, C0. Okay, so it's 0, not fucking C0. So C0. So everything has to be bespoke then. Control Z. From what I can see, everything has to be bespoke. C is equal to 0. So then this comes in. Oh no, this comes in. So Control G, ungrouped. I don't know how to ungroup. Fucking hell, let's delete that. So I know that I'm wasting time, but I can't do anything about that. I mean, I could do something about that, just copy paste and some diagrams online, but that's my understanding in question, not like. So this C0 is going to be C0. This is too close to it. C0. Now I'm gonna group this one. No, can I just copy? Shift this, Control delete, control Z, Control Z, Control Z, Control Z. So now this is, I guess. So this is C0, and then this I do Control C, Control V. Oh, Control Z, Control Z, Control Z, Control Z, Control Z, Control Z. I can't Control Z anymore. Okay, I guess so. Control C, Control V, Control V, Control V, Control V. Hope this fits. one tiny movement of the mouse gets fucked up. So now the sum. That is the problem. Sum. Control C, Control V, delete, Control S, Control. So Control, my friend. Control 0, Control S. Now the sum. Okay, I can still. Okay, so sum. So large S. No, but I can just copy paste this. Control C. No, Control Z first. Control C, Control V, and then just like something like that, and then S, and then what am I adding? I'll look at it in the documentation. In my thing. Control C, Control V, Control C. So like so. Right, is this? Okay, it's the same. Control C, Control V. Okay, so adding. So which is 16, bruh, this is not 16, bruh, skibby toilet. The fuck is that? The fuck is skibidi toilet? The fuck is skibidi toilet? Okay, good. Which is 6, this is 10, 6, so hence we should get the answer 16. Yes, I need this. If I do this, oh my god, so good. Oh no. Oh no, indent is not so a rule is nice. So the rule is color insert white, so I can have this. So if I do something like no, so visa, so I get this. Now if I do something like 1 or 0 1 backslash 1 backslash 0, and then do this, or 0 or 1, so like that, and then we should get so 9 points. This is 2 centimeter. Oh shit, I don't want 2 centimeter, I want like 1.5 centimeter. Is this correct? Okay, so I really need 1.5 centimeter. Does this work? It actually works. It actually works. So I no, this is not good because I will have a 0 here. So insert 0 backslash here. So like so, and then insert insert a backslash here. So it becomes okay. So if I do this, no, it's not good. So if I do a 0 here, so we get this, and then if I do, for example, this and then 1. Oh my god, this is so beautiful. This is so beautiful. But the spaces are fucked up now. Shit. We'll see about this. We'll see about this. Just give me a second. I need the pee break. So, I'm gonna close my mic. I am back. So if I do this again, so 1010 plus 0110, get 0 1 here, 1 here, so 1 here, and then 1 plus 1 is 0, and then 1 here, you get a 1 here, you get 0 here, you get a 1 here, and then you get a 0 here, and then you get a 1 here, so this is 16. So I need to do something like that. I need to do this. Okay. So if I do something like insert 1, and then what do we have over here? We have 1 0. So if I just like do this, if I just shift B, and then if I do something like this, I get something like this. See, very nice. Now if I get something like so, and the 0 I need a 1 here and a 1 there. So for 0 I need a C here and I need a 1 here, and then I need a 1 over there. So yeah, like this, shift B, insert this. So it's a oh my god, now I need to like do this. How do I add a space? Just simply add space. No, this won't add space. This does this add space? Okay, this did add some space. something like so this added space for this one, so I need something like that, and I need something like that. Okay, I need something like that. Why am I okay? I need something like that. Okay, nice. Now this line is going to be about 5 centimeter. This is too big. That's what she said. 3 centimeter. 2.9 centimeter. 2.8 centimeter. Oh my god, this is perfect. Perfection. Perfection. We are going to get the answer. So this is nice. This is 1. Okay, this is 1. This is going to be 0. This is going to be 0. This is going to be 0. And this is going to be 0. This is the binary addition for 1010 plus 0110. If you follow the diagram closely, and then do the addition, do look at the same time, I think you will understand it. Can I do something like so is equal to 16, so underscore 10, and then I was gonna left arrow. So this is it, my brothers from another mother. Let's go back to the diagram. Oh shit. So for beta sequence, so you start with 0. You're gonna get 0. You're gonna get 0 for the sum. Now when you go back to here, you say 1 plus 1. Okay, so I'm fucked up already. So this should be 0. So I need to put a 0 here. Control C, Control V, Control V, Control V, Control V, Control C, Control V, Control V, Control V, Control V here. Okay, nice. Now I get this, and then this, and then this. I want this to be like that. I want it to be like that. I want this to be like that. I want this to be like that. I want this to be roughly like that. Roughly like that. Very nice, very nice. So I get here I'm gonna say 0, and if roughly like that. Can I zoom in more? I can zoom in so much more. Look at this beat. Look at this 0 now. Fuck this 0. Fuck you 0. So it's a 0, 0, and then 0. So I'm just gonna write 0, 0, 0. So okay, so 0, 0, 0. It's gonna be sum of 0, and then this one is going to be 1, 2, 3, 4, 5. I fucked up. Obviously, I fucked up. So 2, 0, 1, 2. Yes. Did he had? Yeah, so 3, yeah. So Control Z, Control Z, Control Z. Okay, good. Guten Tag. and then I'm gonna take a small arrow just like it did in the video. Okay, just like a small arrow, small arrow. Now I'm just gonna take this and just like take this here, Control C, Control V, Control V. Oh, this is not centered. Zero zero, and then the carry becomes 0 for the 0 1. So this is the 0 1, this becomes 0. C1 becomes 0. So now this is going to be 1 1 1 1. Okay, nice. So Juan is gonna be adding to Juan, so you get the here you get the sum of 0. Let's add some things. Let's take these, Control C, close these, and paste this over here. So this is my 0 over here. I'm gonna place it over right over here. I'm gonna place my 1 right over here. So I'm gonna say, oh, delete. I'm gonna say Control C. Okay, there's only gonna be 1, so 1 is gonna be right there, so just paste this over here for the moment. So now just gonna do this, so do this like that, and then so now it's gonna be 1 plus 1. 1 plus 1 is 0. Everyone knows that 1 plus 1 is 0. So 0, so you say Control C, Control V, and then this goes 0 here. Now if you're gonna say 0, the carry is gonna be 1. Oh no, I did something wrong. Wait, what the fuck did I just do? No, how do I redo? I want to redo everything. So this is something technical difficulties happening here. I'm gonna delete that. Oh no, I just fucked up everything. Now it's gonna fuck up everything. Control C, Control V. Okay. Control Z, Control Z. The carry is gonna be 1. So now that the carry is 1, it's gonna be now the carry is 1. As you can see, 0. Control V. V is gonna be V. So we have done this. What happened to my brush? What brush did I choose the other time? Control Z, Control Z, Control Z. Yes. That's this one. Right. Yeah, because I'm not using. Yeah, it's this one. So, so I'm done with this one, and I'm done with this one. Now I've arrived here. So I need to do 0 and 1. So this is A, and this is B. Okay, so I need to do 0 for A and 1 for B. 0 for A, 0 for A, and a 1 for B. Control C. Now I'm gonna remove that one. I'm gonna let it like so. Now I'm gonna say O1 is gonna be so O1 is gonna be a red, I guess. So if I do, is it large? Yes. If I do something like so, I'm gonna say F. No, it's gonna be 1. Then I'll say Control C. Control V. It's gonna be like that. So now it's gonna be 0 and 1. Like I said, it's 0 for A and a 1 for B. So now it's gonna be having a carry from here. So I added here. So this is good. This is good. It's gonna be a sum of 0. So this is also 0. Control C, Control V, and then this is also 0. No. Yeah, I'm here. So this is 0. Now a 1 plus 1. A 1 plus 1 is equal to the carry of 1. So delete this, and then this can go right over here. No, I'm just gonna like this. So this can go right over here. This can go right over here, like so. This no. So it's much better like so. And then I just need Control C, Control V this, and like so. Okay, now it's good. Now this is gonna be 0. Now this 0 1 0 1 because 0, the sum is 0 and the carry is 1. So then this is gonna be 1. This is going to be 1. This is going to be 0. And then this 0 right here, it's gonna be like fuck you, and then like that. And then just gonna say Control C, Control V. Gonna zoom it in. I said, zoom it in. I said, no, that's what she said. So then this is gonna be carry 1. I'm gonna delete this one. I don't need one. This is gonna so this is like that. Then implies so I need the LaTeX. So backslash black, and then the backslash right arrow. No, it's gonna be left arrow. Left, bruh. It's not light arrow. It's left arrow. It's okay. So now I'm gonna say this implies 1. Ah shit. So I'm gonna say close that. Oh shit. Oh shit. F0. F1. F2. F3. F3. Yeah, because it's free. How did he do it? 0 free. Yeah, nice. So initially so small, and then this I'm gonna say Control V, Control C small. Oh no, just gonna drop it down to like here. See now equal to 0. So Control X, Control V right over here. So Control Z, Control okay, and then Control G, and then this can go right over here. So the viewer is gonna, oh no, did you just see that? Did every one of you saw that? Wait, is this live? This is not live, bro. Just nearly lost all my hard fucking work. So, oh yeah, I need to do that now. So, export image, then use scene background color, and this is light, and then this is export to PNG file. For additional bit sequence example, so ripple carry adder example, so, and then this save. Now I'm just gonna say Python len of what? Control Shift U. So len of ripple dash carry adder example 4 bit sequence addition dot png. This is obviously how much. Okay, it's gonna clone on Windows. I have this problem. So I have this problem where I this is my endeavor, so Linux, so oh my fucking god, bro. Control Z, so V. So this is a Linux partition part, and then this is the Windows Win part. Okay, so so if I'm pushing here, push from Linux, the file name issues because too long implies Windows only 257 characters, while Linux, I don't fucking know, but this is the limitation. So I have to make sure that the length of file name is less than 257. It's around 257. I don't have the exact number in my head. So then when I pull here without this, git succeeded, clone successfully, but check out fail. What is checkout? I need to learn. So that is the problem I get. So control Windows 2, Control X, Control V. If I take a look at this, very nice. We don't talk about this. We're not gonna talk about this. So we export image, export as a one-time setting, PNG to file, save, and then this is going to get Control X and then Control V. So like so, and then nice. So this is going to be Control S, ripple. So adders, decoders, and shifters. So where is it? So example of here. So No, this is not good. So uh, a ripple dash carry adder example for bit. So control s cancel. I can do control S. What do you mean that? Control F and O. Oh my god, this is nice. So ripple, and then so I get to do this. Ripple carry other PNG. I'm gonna drop that down to, for example, 1000. Okay, so I can do 200 I guess. No, 200 is too much. So I'll get 75. No, 5. Undo. Or 5. Because initially 0. So yes. Control Shift B. Control readable line length. So if I do appearance, if I do show inline, show zoom level, files and editor. I don't like it like that. Why is there so much unnecessary waste space? See? What is this now? I should push this Control S. So difference series versus parallel. I'm gonna take my explanation that I'm gonna take the notes the conversation conversation. So I'm gonna take the conversation which I had with ChatGPT, chat.openai.com. Yeah. So ChatGPT, and then I'm gonna take the notes. Yeah, basically. So arrive at this point in time. So Control W, Control quit, and Control enter. T new dash S git. Control C. I have this, by the way, cat move. I have this. It basically deletes all my folder in the. So if I do 3 obsidian, oh shit, 3 obsidian. Oh no. So if I do ls obsidian, oh my god, bro, ls obsidian, you have all of this: the confidential vault, the question problem solution vault, and the S.Sunhaloo vault. And then you have this. Basically, what it does is gonna be deleting the folders here, and then this is going to be deleting the, and then adding from the copying the from the GitHub uh, private repo. That is it. Yeah. I mean, the private repo is basically what I show you. That is the private repo, but there's something more to it. So that's why I sometimes show it. I don't show most of it. I just show the learning part and the university part. That's it. So, and I have another thing. So if I do cat.zshrc grep cp underscore og, you're gonna see that I have an alias for copying the S.Sunhaloo folder to GitHub as one. So if I do cd, I'm gonna do rm dash. I don't have a really fancy bash script, so forgive me. I don't have time to learn bash script. I just like what I know, you know. So if I do cd obsidian, if I do cp underscore og, so o to g, so obsidian to GitHub og, and then if I do this, now if I do ls, it's gonna be here. Now I have another alias, so alias cp underscore geo. It's gonna be copying from the GitHub repository to Obsidian. So GitHub to Obsidian. So this is how I did it. Like came up with the thing. So LG for lazy git, obviously, and then you say A, and then you say C. Arrived at series and parallel. So ripple carry adder. So completed the drawings drawings of full the template and 4-bit addition sequence addition. There was a I just showed the commit. I mean, I just showed the commit things, but there was an article or a video, yeah, a YouTube video where they said that your private GitHub repos are not as private as you think, or something like that. I don't care. I mean, I do care a lot, but I'm not putting my really important things. Like, I'm not even putting my OpenAPI key. I don't even have I have an OpenAPI key, but I don't use it. So, it's basically nodes. So, I'm gonna get hacked now. I'm gonna get hacked. Oh no. My GitHub account gonna do it now. Please don't hack me. So, where were we? I think you get the point now. If you want to do something like 8-bit sequence or 16-bit sequence addition, you would need 8 full adders or 16 full adders respectively. We are going to now cover series. So series versus parallel. So, what do I mean by series? If you take a quick glance at the above image for in the 4-bit sequence example, you will clearly see that the full adders are in position / structured in a way to be in C. So span style is equal to color orange, and then this, and then also strong, and then series. So series slash strongs slash span this, and then this. Oh, where is it? Yeah, it's below. So 7k, this 7j, this. So arrange. By the way, I have not configured my NeoVim, anything like that. I just like. Wait, if I do nvim dash dash version, the build type is release. So what is the current NeoVim? So what is the where is the I need NeoVim. So NeoVim. So where's NeoVim? Yeah, NeoVim. So what is the current release? It's a built up release. Where is the uh testing? Like the I don't know, I forgot. This was released 2 weeks ago. My god, Arch Linux is so good. Arch Linux is so good. So yeah. So I have not configured my NeoVim, so I will be configuring one day. I will be learning how to configure it, but I don't really have the time for it right now. So let's continue. So we'll place that the position in a structure so in series. But then I ask myself, why are ripple carry adders called what? Parallel adders. Tenuous bit addition. So if I do something like pulse audio, I'm gonna test the input. You see I have 17. I'm gonna test if it becomes like zzz sound that I'm gonna test. I'm gonna like do like -14. So we are going to, what am I doing? What did I just do? What am I doing? It was -17. So 25. I'm gonna try 25. No, I think 25 is too sensitive. Yeah, it's too sensitive. So I'm gonna drop it down to like 20%. I think I'm gonna try this. Control S. I don't know. So yeah. they also have bit by bit addition. Ooh, what's that? Your mom. Uh, basically, bits of the numbers to be added are fed into the full adder psi. So span, I could just take that above. So if I do so yank this on 1J or 2K. So if I do paste this here, if I do like change the colors to like green or something, and then I do like simultaneously. Okay, nice. I know how to type English simultaneously, and then dot. So y ripple carry that is considered as parallel. Yes. The simultaneous processing of bits. The actual addition of the corresponding bits are performed in parallel. Full adders are working at the same time same time processing their respective bits. So leaves the C out from the previous stage. stage. Yes, brother, yes. Yes, brother. I get the point.
We can add the output carry of this one valid sum bit and the carry bit will be available. And using 4 such full adders, this 4-bit adder is designed. So considering this, now let us understand the issue or the limitation of this 4-bit adder. So here, although the input bits to the all full adders are applied simultaneously, but the availability of the each valid carry input depends on the previous stage. For example, these full adder
Okay, I'm gonna go now. Oh, I'm gonna go later. Let's stop talking.
For example, so once this C1 bit is available, then this full adder FA1 will generate the sum and the carry bit after its own propagation delay. That means this C2 and the S1 will be available after 15 plus 15 nanosecond, that is equal to 30 nanosecond. So as you can see, the last full adder has to wait till 45 nanosecond to get the valid carry input, and after that only it can perform the valid addition. That means these C4 and the S3 will be available only after 16 nanoseconds. That means for this 4-bit adder, we will get the valid sum result only after 16 nanosecond. So in general, we can say that the full adder at the MSB position has to wait until 3 TC time, where TC is the propagation delay for generating the carry output for each full adder. So full adder means full output is equal to full adder F1 output till all propagation delays C2 input is availability. Let's say both these times are 15 nanosecond. The valid this 4-bit adder is designed. So considering this, now let us understand the issue or the limitation of this 4-bit adder. So here, although the input bits to the all full adders are applied simultaneously, but the availability of the each valid carry input depends on the previous stage. Although the input bits to the all full adders are applied simultaneously, so here, although the for example, this full adder FA3, although the input bits to the all full adders are applied simultaneously, but the availability of the each valid carry input depends on the previous stage. For example, this full adder FA3 cannot perform the valid addition although the input bits to the all full adders are applied simultaneously. This the addition nanosecond input adder addition where the n minus 1 times Tc plus Ts required to generate the valid sum output is equal to n minus 1 times Tc plus. This time you can see in this carrier the time which the limitation propagation delay is adder in given design. The propagation delay of the each XOR gate is equal to T XOR and the propagation delay of the each AND and the OR gate is equal to TP. So here this T XOR is equal to find the verb output. So in this case, this sum output is available after 40 nanosecond, while this carry output is also will be available to time which is required to generate the C1 input. And this 2TP
Goodbye, my